I'll start with the topic, and that is additional instructions. Instructions which can be easily understood. The byte transfer can be easily seen in these instructions. Okay, so you are learning few instructions of the assembly language. Okay, so that is logical instruction, shift instructions, and rotate instruction. So as you had seen, the not in logical instructions, there are three instructions: not, and, or. Okay, uh, like these three instructions you are studying for this semester. Fine. So not instruction, the format is this, that is, opcode there is opcode and the destination. Okay, so whatever the operation is mentioned here works on this location, whatever is mentioned in the destination. Okay, so here it is not, and the example given is r not, means the not operation, the not instruction is working on r not register. Okay, so what not instruction does is the content, whatever the binary bits, whatever is stored in this particular location of operand is reversed. The bit patterns are reversed. Okay, that is 0 becomes 1, 1 becomes zeros. Okay, it is like complement. Uh, it is a complement of the particular bit. Okay, so it is used in finding the ones complement and answer two's complement. So after getting one's complement, you add +1 for getting the two's complement. So if the bits are 1 1 0 1, one's complement is 0 0 1 0, and that is what you get when you do the not operation. Okay, when you add +1 to this, it is 1 1 0 0, and this is 2's complement. Okay, so this not operation, not instruction is used for finding the one's complement and two's complement. Okay, so that is not instruction. Similarly, there is and or instruction. So and instruction is the logical and operation, what you have seen in the C programming. If there is if statement. Okay, so or any condition checking, if there is condition 1, okay, and condition 2. Okay, there are two conditions. So this, if two conditions are true, then it will come to the loop, the statement. Correct? So you can give conditions like this: if I is less than 2 and I is greater than 20. So what should happen? The instructions will be written. So it works only when the conditions are true. Okay, that is if if both conditions are true, that is 1 1, then the condition is true. Okay, the format of and instruction is and opcode, that is and source and destination. Okay, so r0 is source and r1 acts as both source and destination. Okay, so if r0 content is this and r1 content is this, then and r0 comma r1 gives the result in r1. Okay, what is the result? Wherever there is 1, there will be 1, and any other combination. Okay, so 0 0 is 0, 0 1 is 0, and 1 0 is 0. Only if both conditions are true, then it is true. If both is and, okay, if both conditions are true, so one true and true, it is true. Okay, that is and operation. Next is or. In or operation, anywhere one is there, then it is 1. Okay, so that is, if I am writing a condition, if C1 or C2, that is, if any one is true, or both are true, then the condition is true. Correct? That is 0, 0. If both the conditions are false, then it is false. Any one is true or true, it is true. Any one is true, it is true. And both are true, it is true. Okay. So this is OR operation, OR instruction, or R not R1. The result will be in the R1 register. Okay. So this is R0, this is R1. And wherever there is 1, here there is 1. 1, 0 is 1. 1, 1 is 1. Okay. 0, 0. When the combination is 0, 0, it is 0. Okay. This is OR operation. So these are the logical instructions. Next, we'll see the shift instructions. Okay, so as I told in the class, shift means the bits of the register or bits of that particular location is shifted by 1 bit. Okay, it is shifted by 1 bit. And also, if we are using this instruction, the shift instruction, the syntax is count, comma, destination. Okay, so there are 2 operands. Count gives by how many bits the shift should happen, and destination on which memory location or on which location where the bits should get transferred. Okay, so whenever there is left shift, so there is left shift, the bits move towards the left, the bits are shifted towards the left. Okay, when there is right shift, the bits are shifted to the right. Fine. So we'll see the instructions one by one. Okay, so there are 2 main shift operations. Okay, logical shift left and logical shift right. And the logical instructions, there is logical shift right and logical shift left. Okay, so we'll see the logical shift left instruction. So as the diagram shows, the bits of R0 register have to be shifted to left. Okay, by how much it has to be shifted? It depends on what the opcode value is. Okay, operand. The first operand value, whatever is there, that indicates by how many bits by how many bits the shift should happen. Okay, now we had seen the carry flag in the conditional flag instructions. That is, wherever there is an overflow, the overflowed bit is stored in the carry bit. It is in it can store only 1 bit. It is a 1 bit flip-flop like structure. Okay, so it is 1 bit flip-flop, either 0 or 1. Any one value is stored. Okay, so whatever is overflowed. Okay, andre suppose these are the values, this is the value. Okay, I am using logical shift left. Okay, left shift, and there is carry flag. Carry flag by default it is set to 0. Okay, by default it is set to 0. This is the content of a register. So when I am shifting to the left, suppose it is left shift by 1. Okay, so the whatever content is there in MSB is shifted, is moved to the carry bit. Okay, followed by this 1 to the most significant bit position, then 0 and 1. Okay, there is a free space, free bit space. So in that position, 0 is added. Okay, 0 is added. So here you can see in the diagram, 0 is added to the least significant bit position. Always when there is a left shift, we say that it is the the left shift operation is, what it does is, it is like multiplying by 2. When I'm shifting the contents to the left, it means I'm multiplying the value whatever is there in that particular register by 2. And if I'm shifting to right, the value reduces by 2. It means it is like divide by 2. Okay, I'll just show a positive number example. If I take okay, 1010, I take 10. Okay, this is 10, and there is carry bit here. Suppose I do left shift by 1, okay, by 1 bit left shift. So what happens? Carry bit becomes 0. It was 0 only. However, this MSB goes, okay, and there is 1 0 1 0, okay, and there is a space. So by default the space content is 0. So the value here is 10. When I do left shift by 1, it is, the value is multiplied by 2. Okay, so that means the value must be 20 here. We'll check whether the value is 20. So this bit position is 2 power 0. This is 2 power 1. The value of it is 2 power 1. Place value in binary. Okay, this is 2 power 2, 2 power 3, and 2 power 4. Okay, now find the value, what it is. So this is 1 into 2 power 4 plus 0 into 2 power 3 plus 1 into 2 power 2 plus 0. Okay, now this both are zeros. Equals 2 power 4 is 16 plus 0 plus 2 power 2 is 4. 4 into 1 is 4. So it is 20. Okay, so left shift is multiplied by 2. Once you shift the bits left, it is multiplied by 2. The values gets multiplied by 2. Okay, so these shift operations are used for the arithmetic operations. Fine. So actually the problem will be given like this: left shift, okay, the how many times and R naught. From this you can directly write this answer. Okay, but sometimes you may get confused, so I have used 2 steps. Okay, after first shift, what is the content of R naught? So there will be a free space which is created here, free bit space, that is filled by 0. Again, after second shift, that is, this contents are shifted again to left for the next time. Okay, so the 0 moves to the carry bit, and 1 0 1, so 1 0 1, 1 0 1 0, so 1 0 1 0, and then one free bit space is created. It is filled with 0. Okay, as the diagram shows. Here you can see it is filling with 0. Okay, the bits are moved, when the bits are moved to the left by 1. Fine. This is logical shift left. Okay, now we'll see logical shift right. What happens? So the bits are shifted to the right. Okay, whatever bit comes out of this LSB is moved to the carry bit. Okay, so the operation, the instruction opcode is L shift right, L shift R, which stands for logical shift right. Okay, so here also, from this problem, if this problem is given, means they may ask after this particular operation, what is the content of R naught? You can directly write R naught value, but if there is confusion for you in doing, it is better you shift once. Okay, so shift once, that is right shift. So what happens? 1 moves to carry bit, and then 0 1 1, so 0 1 1, and 0 1 0 1. So 0, 1, 0, 1, a bit space is created, fill it with 0 as the diagram shows. Okay, and then again this are not content, the present are not content is shifted to right again. So 0 moves to the carry bit, carry flag, 1, 1, 0. So 1, 1, 0, 1, 0, 1, 0, 1, 0, 1, 0, and then a bit free bit space. It is filled with 0. Okay, we'll see the value of 10 here. That is previous example we had seen. 0, 1, 0, 1, 0. I'm moving to the right by 1 bit. So this value is 10. Okay, this is the carry bit. By default it's 0. This value is 10. Okay, after the right shift by 1, what should be the value? It should be 5. Correct? So the carry bit, right shift, 0 goes to the carry bit, 1, 0, 1. So 1, 0, 1, 0, and free bit space, it is filled with 0. Okay, so you can see the value is 1, 0, 1, which is nothing but 5. This is 2 power 0, 2 power 1, 2 power 2. 2 power 2 is 4 plus 0 plus 1 is 5. Okay, this is logical shift right. Any doubt? Listening?
Yes, ma'am.
Okay.
Yes, ma'am.
Any doubt, students? You can ask me now regarding the shift operations. Okay, so one more shift operation, that is arithmetic shift right. So what happens whenever there is the suppose the register has this particular value. Okay, so I have told that any value, any integer value, suppose it is the MSB is 1. If the MSB is 1, it means it is a negative number. That is, MSB indicates the sign bit of the operand value. Okay, so in a storage space, the whether it is memory or the register, and if it is a numeric value, okay, you are accessing a numeric value. When it is a numeric value, integer which is stored there, the most significant bit indicates this, acts as a sign bit. Okay, means if it is a negative number, I put the most significant bit as 1. Okay, now when I just do the right shift, the content is moved and there is free space and 0 gets filled. That means this negative number becomes a positive number. Correct? So whenever there is an arithmetic operation which is done in the problem or in the programming, assembly language programming, you use arithmetic shift right. Okay, means you want to retain the most significant bit value, whether it is negative or positive. Okay, so the value, most significant bit value is retained. Other than that, it is the same right shift operation, and this bit is shifted to the right. Okay, but the MSB bit value, whatever is there, 0 or 1, it is retained. Okay, that is arithmetic shift right. Fine. So we'll just we'll move forward to the next operations, next instructions, that is rotate instructions. Okay, so rotate instructions, there are 4 rotate instructions. To rotate the bits, the register content, it moves left or right according to the number of bits which are specified in the operand. Okay, so yes, we'll go to one. So rotate left without carry. See here, you have seen the carry flag which is used in the shift operations. Okay, so in rotate, what happens is the content what was removed, okay, when I'm moving to the left shift, the MSB value is moved back to the initial position, that is as LSB. Okay, so this is the rotating of bits. Fine. So here the rotating same the format is the same: opcode, count, and destination. Okay, by how many bits the shifting of bits should happen, and whenever there is a shift, the value which is taken out from the register is moved back to the other end. Okay, that is rotate instructions. So there are 4 rotate instructions: rotate left without carry, rotate left with carry, and rotate right without carry, and rotate right with carry. So what is the differences? When I am rotating the bits without carry, okay, I'm rotating the bits without carry, the most significant bit value is moved to the carry bit, but the carry bit is not affecting the value what is moved to the value moved as LSB. That is, 1 is directly moved as LSB. Okay, coming to rotate left with carry. So with carry, you can see the diagram. The bits are not moved directly from here. From MSB, the bits are not moved directly to LSB. It moves through the carry bit. Okay, it uses the carry flag. Okay, so this is rotate left with carry. Fine. Okay, now you can observe the opcode. This is rotate left. Okay, rotate left by 2 bits. So to avoid confusion, we are doing step by step. First, one shift, what happens is this 1 moves to the carry flag, and also this 1 has to move to the least significant bit. Okay, so this 1 has to move to the least significant bit. These bits are moved, shifted to the left. Okay, that is 0 1 0. So 0 1 0, 1 1 0 1, 1 1 0 1, and in this free space what is there in the left shift operation, it was filled with 0, but here this is rotate left shift. So whatever content was removed from MSB is pushed back to the least significant bit. Okay, so this is the first rotate. Next, in the actually the instruction is rotate twice. So rotate twice, 0 comes to the carry flag, and then it also is moved to the least significant bit position. These bits are moved to the are shifted by 1 to the left. Okay, here first shifting of bits is happening, and this is the answer with second shifting of bits. Okay, the carry flag is not affecting the value what is there in R0. Okay, carry flag is not considered. It is without carry. That is the first instruction. Next is rotate left with carry. Carry flag is considered. Okay, so this is the register content, and this is the carry flag. You are shifting to the left, so 2 shifts are required. I'll first shift by 1. Okay, so by 1 I'm shifting first. So 1, that is the MSB, moves to the carry bit. Then it is 0 1 0 and 1 1 0 1. So 1 1 0 1. The value what was in the carry bit is moved to the LSB. Okay, in the diagram you had seen the value what is there in the carry bit is moved to the LSB. Okay, so after the second shift, this is the second operation of shifting of bits. Okay, 0 is moved to the carry flag, and then the bits are shifted to left. A free space is created. 1 which was there in the carry bit is moved as LSB. Okay, so if the bits are 1 1 0 1, okay, so 0, these are the bits, and there is carry flag which is initialized to 0. Okay, by default it is initialized to 0. Suppose I am rotating it twice, the bits are shifted twice. Okay, so in the first shift, 0 is added here. This is the 0, which is most significant bit. 0 is moved to the carry flag, and then there is 1 1 0 1 1 1 0 1. There is a free space which is created. Whatever value was which had come out of the carry flag, 0, is moved to the LSB. Okay, in the second shift operation, most significant bit is moved to the carry flag. 1 1 1 0 1 0, free bit space is created. Whatever value was taken out of carry bit, that is 0, is moved to the LSB. Okay, this is rotate left with carry. Fine. Similarly, there is rotate right without carry and rotate right with carry. Okay, so the syntax, that is the format, is the same. This is rotate R instruction, rotate by 2-bit, and then R naught content are to be rotated. Okay, now this is without carry, so carry flag does not affect the content of R naught register. However, the least significant bit, that is, I am doing the right shift, so the least significant bit is moved to the carry flag. Okay, and then this content are rotated. Okay, so the bits have to be shifted to the right. So 0 1 1 0 1 1 0 1 0 1. Okay, it is written here. There is a free space. Okay, so there is a free bit space which is created here. I had told the content of LSB moves here directly to MSB. Okay, the carry flag is not affecting, so from carry flag 0 had come out, but it is not affecting the R naught register. Fine, so this is rotate right without carry. Carry flag is not used for moving of bits. Okay, directly whatever content was there in LSB is moved to the MSB. Fine, this is rotate right with carry instruction. So rotate right with carry, rotate RC. So here you can see the bits are shifted by 1. So this is the first shift of bits, and this is the second shifting of bits. Okay, so 0 1 1, this 1 which is there in the LSB is moved to the carry bit. 0 1 1 0 1 0 1. So here there is a free space which is created. So whatever value was taken out of the carry bit, that is 0 was initially there, 0 was taken out of the carry flag, it is moved to the most significant bit position. Okay, similarly this value which was in the next shift, 1 is taken out from the carry flag, that is moved to the most significant bit position. Okay, so these are the rotate operations. You have seen the logical operations, shift operations, and rotate operation. Okay. So these are few additional instructions. Any doubt you can ask me. And yeah, we will end today's class. Next is stack the topic. Or okay, we'll see that later. So any doubt you can ask me now.